Today we're going to be talking about polynomials, classifying them, evaluating them, also writing polynomials in the standard form. So here's some vocab words. There's going to be some vocab words for today, and it's really just setting the premises for the next couple sections where we'll be doing more of the math stuff. This is the basis for it. So take a minute, copy down your target, try these two warm-ups. They are supposed to be a little more difficult. I really want you to pause the video here and really try them on your own. Make sure you have something written before you watch me solve them because they are a challenge and you're only cheating yourself if you don't try them yourself. When we look at this first one, you have to remember your rule. It looks really intense, but our rule was if we're dividing the same base, we subtract the exponents. So you're going to keep that base of 3. But you're going to have 2x minus the exponent in the denominator. Notice I put parentheses there because you're subtracting that whole thing. So this is really 3 to the 2x minus 2x, and then minus a negative 1, guys. It's actually a plus 1, which means these just cancel each other out, and you're left with 3 to the first power, which is just 3. So it looks really intense, but it simplifies all the way down to 3. For the second one, you have the base of x plus 1. Your base can be a binomial. So you have x plus 1. Same base. What do you do with their exponents? You keep the base, and then you subtract their exponents. 2 minus 3 is going to be x plus 1 to the negative 1. And we know that negative 1 cannot stay in the exponent, so it's 1 over x plus 1. And there's your answer. So I hope you tried those. I hope you challenged yourself. They are different, but they are not too hard when you just think back to your rules. Couple vocab words, guys. So a monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So it's a number or a variable or a product of numbers and variables with whole number exponents. Monomial, okay? The degree of a monomial, then, is the sum of the exponents of the variables. So you add up the exponents of the variables. Remember, a constant it's just a number. Constant's just a number, so it doesn't have any variables. Maybe it's like 7. So it's also the same degree as to 0. Because if I have 7x to the 0, remember we know x to the 0 is just 1. This is just 7 times 1, which is really just 7, right? It's a constant. What would the exponent of the variable be? It would be 0, okay? So here's a couple examples of monomials. 5, just a number is going to be a monomial. Just a variable like x could be a monomial. Remember we talked about addition and subtraction are the operations that separate terms. So when you have negative 7xy, there's only multiplication in there, which means that is one term. It is a monomial. And then, you could have a fraction or a decimal in front of it as well. Something that's not a monomial. Take a look at the next one. The next one, why is this not a monomial? Where is it failing? It does not have a whole number exponent. Okay, if you rewrote it in fractional form, like they have this one in, it still technically doesn't have a whole number exponent. And then the next one, we just had addition and subtraction separate terms, so that has 2 terms, okay? So here, look at this chart right here to recognize some monomials. When we want to find the degree of each monomial, remember that the degree is the sum of the exponents. That's what you're going to do. You're going to sum up the exponents of the variables. So you're only focused on the variables. Take a look at this first one. Where are my variables? P and Q. What are my exponents of them? 4 and 3. So what's the degree now of this whole term? It would be degree, 4 plus 3 is 7. What would your degree be for letter B? You're only looking at the exponents of the variables that you have. You have variable E and variable D. So what are their exponents? What would be above there? You would have to the first power and to the first power, so together that would give you a degree of 2. Last term then is just a constant. We know a constant has a degree of 0. Okay? So you'll be practicing more of those later, but these are degrees of monomials. We can also find the degree of a polynomial. And a polynomial, guys, is a monomial or a sum or difference of monomials. Basically, it's just more than one. A monomial means means one term. Polynomial can have more than one term. And the degree of the polynomial now is going to be the degree of the term with the greatest degree. Okay? So you're only going to take the degree of the term with the greatest degree. So we look at this next example. In order to find the degree of each polynomial, you have to first find the degree of each term. What's the degree of 11x to the 7th? Well, it's just 7. What's the degree of 3x cubed? Again, it's just the exponent of the variable, so it's 3. You take the greater of the two, and you don't add them or anything, it's just you just take the greater of the two. So this would be our degree of our polynomial. It would be 7. I want you to try B as well, and I want you to try to write the degrees of each one first, and then write the degree of the whole polynomial. The first term here would have a degree of 2, and don't forget there's a 1 here, so it would be a degree of 3. The second term has the variable z, which the exponent is 4, and that's your only variable, so that's your only degree. The last one is a constant. Constant, guys, degree is always 0. Then you choose the highest one. So this whole polynomial altogether would have a degree of 4. All right, so we learned monomial, degree of a monomial, polynomial, and the degree of a polynomial so far. A term of a polynomial may be written in any order, okay? However, the polynomials that contain only one variable are usually written in standard form. And here's what standard form is. The standard form of a polynomial that contains one variable is written with the terms in order from least to greatest degree. So in order from least to greatest degree, you need to write that down on your note sheet. If you're taking notes on paper, you need to write down this whole thing. If you're filling in the note guide, you can fill in just the blanks. Then when written in standard form, the coefficient of the first term is called the leading coefficient. So it leads the entire polynomial. It's the first number that you see when it's written in standard form. So for example 3, I want you to write each polynomial in standard form and then give the leading coefficient. Okay? And you could probably do this without me leading you, but look for the one that has the highest degree. So we might want to look at each degree first. This term would have a degree of 1. This term would have a degree of 5. Next term would be a degree of 3, and the last term would be a degree of 0. Now all you do is write them in order from greatest to least degrees. Guys, don't forget to keep the sign that's in front of the term with it. So my first term, the highest degree, is going to be this one right here, and that's a negative 7x to the 5th. My next one is going to be this one, which is plus 4x squared. 6x is really a positive over here, so it's plus 6x, and then it's plus 9. This is in standard form. You're going to try to write all of your answers in standard form in descending order based on the degree. The leading coefficient then would be what? The leading coefficient here is negative 7. It's the coefficient of the very first term. Try the second one now. You probably really don't even need to write the degrees. You can probably just go to it, look for the greatest degree. It's going to be negative 4y to the 6th. Then this is a degree 2, this is a degree 1, so we're going to go with the y squared. It's a positive y squared, and then a minus 3y. There's your standard form. If you check your degrees, they go in decreasing order. And then the leading coefficient is the first number that you see on the first term, so it's a negative 4. Pretty easy, right? This is, again, just setting the tone so we can use these vocab words for the next couple sections, so when I'm explaining things, you'll know what I'm talking about. I do want your answers written in standard form, though, so get used to this. We can, of course, classify these polynomials, and some polynomials have special names based on their degree and also the number of terms. So you're going to use one word from each table, okay? If it has a degree of 0, we're just going to call that a constant. That's just a number that's standing alone. If it has a degree of 1, well, we learned this is like having x to the first. And if I had y equals x, what kind of graph would that be? That would be linear. If I had y equals x squared, the highest degree is a 2, what kind of graph would that be? Hopefully you're saying a parabola or a U. What do we call that? Quadratic. Same thing, think of like x cubed. We haven't talked a lot about this, but we have mentioned it. X cubed would be a cubic function. 4 is quartic, think of quart. 5 is quintic. And then once you get past 5, we just call it by the degree. So if it has a degree of 6, we would call it a 6th degree polynomial. If it had a degree of 7, we would call it a 7th degree polynomial. So that's going to continue on. Anything higher than 5 won't have a special name. So you're going to use one word from that table to describe or classify the polynomial based off its degree. And then you'll use one word from the second table over here, which will describe the number of terms. So we're going to describe the degree and the terms. If it has one term, you've already learned this word, it's a monomial. If it has 2 terms, you probably heard me say it, and think about it, what would we place mono with? A binomial. 3 terms, guys, 3 wheels, trinomial. And then anything more than that is just called a polynomial. So remember, a polynomial can be used to describe 1, 2, or 3 terms, but it also is specifically used to describe 4 or more terms. So last example of the day, pretty easy notes. I want you to classify the polynomials according to the degree and the number of terms. We'll base it off a degree first, and then we'll follow that up with the number of terms. This first one, highest degree is 3. What do we call something that's a degree of 3? Cubic. And then it has how many terms? 2, so it's a cubic binomial. Next one, highest degree is, it's already in standard form for you, so you're looking at the first one. It's a 6th degree, and then it has 1, 2, 3, 4 terms, so it's a 6th degree polynomial. Last one, guys. What do we call this one? What's the degree again? If it's not written, it has an exponent of 1, so it's a linear. And how many terms do you see? Just 1, so it's a linear monomial. All right, guys, that's it. Don't forget to do your quick check on blended schools.